One of the methods we can use to multiply polynomials, whether they be binomials or trinomials or any type of polynomial, is what I like to call an area model. My area models take the form of rectangular shapes. And we need to remember that when we're finding the area of a rectangle, it's going to be base times height or length times width. So what's going to happen is each term within the polynomial is going to represent a measurement for each section of each side of my rectangle. So for example, the binomial 2x plus 3. The term 2x represents the distance from the top left corner to the middle of the left side. The plus 3 represents the distance from the middle of my left side to the bottom left corner. With the binomial x minus 3, x represents the distance from the top left corner to the middle along the top side, and the minus 3 represents the rest of the distance across the top. Now I have the 4 quadrants, and I have 4 different measurements that I'm going to use to find the area of each region. So to find the area of the top left quadrant, I'm going to take the 2x times the x, my base and my height. So 2x times x is 2x squared. And then for my top right quadrant, I'm going to take 2x times negative 3 is negative 6x. For the bottom left quadrant, we're going to take positive 3 times x for a positive 3x. And for the bottom right, we're going to take positive 3 times negative 3 for a negative 9. Now, once you have the area of each region, you're then going to write the polynomial formed by combining the terms of these regions. So first I'm going to write out all of the areas of each of the regions, 2x squared minus 6x plus 3x minus 9. And then you'll see I have 2 terms in the middle that are like terms. So those 2 terms can be combined, 2x squared minus 3x minus 9, and we have multiplied 2x plus 3 times x minus 3. Let's try this with 2 more binomials. So all you need to do is create a box, a lot of my students like to call it, with 4 regions if it's a binomial times a binomial. And along one side, write the terms of one binomial. And across the other side, write the terms of the other binomial. And then using the measurements of each side of each quadrant, multiply to find the area of each region. So p times p is p squared. P times negative 8 is minus 8p. 3 times p is positive 3p. 3 times negative 8 is negative 24. So we ended up with p squared minus 8p plus 3p minus 24. Again, I have my like terms in the middle there. So my final product, my final answer is p squared minus 5p minus 24. And for my last binomial times binomial, create my model again with my 4 quadrants. We have n plus 2. And we have n squared plus 3. N times n squared. So we'll have to use our properties of exponents. This is n to the first, so this becomes n to the third. N times 3 is plus 3n. 2 times n squared is 2n squared. And 2 times 3 is plus 6. And this 2n squared is also a positive 2n squared. And when I write this, I'm going to write it in standard form, starting with the largest exponent. So we have n to the third plus 2n squared plus 3n plus 6. And this polynomial does not have any like terms, so that is our final product. That is our final answer.